So now we will go to the next speaker, which is Cecilia Puga. She's architect from Chile. She's a designer of many buildings, but she's also a professor, has been invited professor in several universities like Texas, like Harvard, like Zurich, or like Barcelona.
Well, before starting my presentation, I want to thank very much Joseph Schwartz and Aurelio Mutoni for this invitation and all the team of the FIB Symposium on Conceptual Design of a Structure. I am very glad to be here today, and I will start in a very open way, explaining the way we introduce in our studio, in the academic field, and in terms of pedagogical and methodological purpose, to understand architecture and how to work within the project studio that we do. So in our work studio, we propose a student to understand architecture as the field where the three systems interact, and which I will describe only through image collection. The first, which is the image you have in your screen, is a relational system, and it refers to the relation that the project established between spaces and volumes, and the way in which these are linked to each other and to their context, understanding that different configurations determine system of cohabitation and interaction between people, and therefore configure way of life. This system of relation are where the project negotiates degrees of freedom and control, how individual and collective experience is outlined, and what are the degrees of interaction involved in the proportion. Within the system of relationship, we distinguish four families of category, which we have defined as field, fluidity, articulation, and grid. The second is the atmospheric system. It tries to stimulate through the use of categories using photography, the ability to read, understand, interpret, and dissect a wide range of atmospheric quality of a space resulting from the experience that they allow. The categories by which we try to describe the quality of environment are color, polychrome or monochrome, resolution, high definition, low definition, saturation, high density, low density, and brightness, overexposure, low exposure. Finally, the material system. And when we speak of material condition, we refer to all those aspects that constitute the physical and palpable body of architecture, of what shapes the space that men inhabit. It includes material, constructive system, and of course, structural system. The purpose to understand the material system as the result of design operation aim to achieve certain quality of the space that will define the inhabit experience. Therefore, we define the project material system obliquely as the result of a quest of build a certain quality of the space, a specific sonore, visual, acoustic, and cultural experience. Among material, we propose four families: isotropic, compound, continuous, and planar. In our professional work, we always start by defining what experience is that we want to offer, how we imagine that ambience, what tone it has, what density, how much information, etc. Only once the image begins taking shape, we proceed to think about what material system, and therefore structural and constructive, will help us to materialize that purpose. We are interested in the notion of architecture as an entity which erases somehow the border between the material system, structure, and architecture. it is somehow about trying to leave narrative aside to favor construction and material processes. I would like now to show you two projects, one that has been built, one that we would love to have the opportunity to build sometime. So the first one is the new headquarter of the Chile Ministry of Culture, Art and Heritage that we developed together with my partners Paula Velasco and Alberto Moleto after winning a competition on 2014. The commission consisted in the recovery of a ruin, the old Palacio Pereira, a simple two-story masonry structure built in 1873 by a French architect, Lucien Henault, and the construction of a new building on the ground that successive demolition and earthquake had freed inside the property. The project therefore implied a negotiation between the pre-existence and the new structure, between different time, material, and technology. In this, as in other projects, the exchange with our engineer Pedro Bartolomé and his team began in the competition stage once we had a clear understanding of the intervention criteria for the pre-existence and an idea for the new building that convinced us. This included the layout, the operation, the material decision, and a proposal for the structural system. From that moment on, and during the whole project phase, a negotiation with engineer was established in which they have to ensure the structural viability of the project, accepting some rules or principles established by the architect that were not negotiable. From very early on, we understood together with engineer this heritage recovery as an operation that had to restore not only the spatial symbolic aspect of the building, but also the technological and fundamentally the original structural performance of the building. This forced us to carefully delimit and define alongside engineering and our advisor the operation destined to the structure consolidation methodologies, processes, and materials to be used so that everything will contribute to the building structural operation as it was conceived. The aim was to have as few interventions as possible, a small number of accurate operations that may ensure the stability of the building facing future earthquakes. The construction of a rigid diaphragm in concrete over existing wooden, a 7 centimeter diaphragm in concrete over existing wooden beam that held all walls and facades together was one of them and is what is shown in this drawing. And the reinforcement of every existing opening with a 10 millimeter thick embedded frame along and 20 centimeter wide, alongside the repair of infinite cracks, solved the issues of stability that the historical structure had. And in this picture on your left, you can see this operation. Here you can see the steel frame that we put in all the different opening, and also the new slab in concrete with these perimeter beams in concrete, and at your right, the final result of the recovering of this area. So now I would like to show you some images about what was the result of the works very briefly. So this is the facade restoration. And what you see here is the recovery of the layers of the 19th century that were existing behind the several layers of industrial painting and intervention. And this is the recovering of the interior gallery that it's open air. It's enclosed, but with a glass. It's a glass gallery, so there is a lot of light in it, and this is the way it is now. And these are part of the brickwork that was remain exposed with this helicoidal stair we put inside to communicate the two floors of the building. Most of the western area of the plot was empty. The original scheme of an exterior courtyard in the back was not visible anymore. Following the footprint of the original typology of the palace, which related the gallery in the forms of cross with the courtyard and its side corridor, we wanted the new building to be held responsible for filling the blank resulting from successive demolitions and collapses, giving back to the building its space structure in a contemporary way. The infilling of the structure gives shape to a new courtyard that stands in the same area as the original garden of the Pereira family. At the same time, the new structure embodies the negotiation between all historical time collapsing in one space. The idea of simultaneity and coexistence of different periods and epochs overlaps. Using the image of a scaffolding, the new structure emphasizes the temporary and dynamic condition of what we understand for intervention on heritage, alluding to work in process. A structure that allows light and air to get inside and revealing the view of the original structure associated to it. We use a noisy and dense isotropic concept for the structure, using branch-shaped light concrete column of 25 per 25 centimeter, in contrast to the continuity and massiveness of the masonry walls, creating a high-density inner perimeter around the new courtyard. Those columns and geometry allow us to hold the building on the side adjacent to the heritage building, away from its wall and interior facade, any vertical element of the new building. The fingers that you can see in the picture in your right of the structure moved according to specific structural requirement of each area to ensure the structural autonomy of both pieces. The grid of pillars and beam, along with the party wall, constitute the seismic structure of the building and create a view that we hope will help to produce a particular vision on history and time by means of the light and shadow reflected on the remain of Palacio Pereira and the site of this temporary layer of coexistence. Between, as it was said by David at the beginning of the presentation, between 2017 and 2019, I was visitor professor at the ETH School in Zurich. Since the material constructive and structural aspect were central on my studio with the students, we invited Joseph Schwartz and Lucas Ingold to some of our review, in which a very interesting and challenging dialogue was established with the student and with me. In addition, Paula Velasco, my studio partner, and I were familiar with Joseph's professional work and some of the research that his team of doctoral and postdoctoral students were doing at ETH. We were very interested in his understanding the structure as a highly powerful agent and bearer of meaning for architecture. During this period, our studio in Santiago was shortlisted for an architectural woodworking competition, and we dared to invite Joseph to participate with us. He accepted and joined our team with enthusiasm together with Pierluigi D'Acunto. The idea was to design an institutional building to house the headquarters of the Empresas Arauco, a holding company dedicated to the wood industry in Chile. The call for proposal sought, at least on the paper, not really in the results of the competition, a proposal that will put the company at the forefront of the technological innovation process in timber construction, in high altitude, not high, but middle altitude, developing systems with industrial potential. The work began in our office in Chile, defining some issues that had to do with the requirement of the program, the site, and the indoor environment we wanted to achieve. From the beginning, we wanted to avoid working with conventional system of pillar, beams, and CLT slabs. We liked the idea of achieving clean and calm surfaces in wood and a very transparent and light building. The idea of using shell systems seemed attractive to us. We started by proposing the use of a structural vault system that we had already used in other projects. However, for our first meeting, and in case Joseph didn't share our enthusiasm for vault, we added two more alternatives, but he quickly discarded this and became interested in the one we liked the best. And there it all went forward. In successive meetings in his office at ETH, Joseph pushed and conceptually radicalized the structural proposing, incorporating post-tension for wood. And all the issue and solution, the project development was done in Santiago, incorporating all the issues and solutions that we had discussed and drawn in Zurich. Then Joseph invited Joseph Blumen-Lehmann and Martin Bender generously went to Zurich on more than one occasion to review the technical and economic feasibility and help us define a possible production and assembly process. Our project attempts to explore new type of architecture helped by the precision of prefabrication method and the consequent speed of construction processes, in an effort to move the boundaries of that which is possible to become a consistent and significant contribution to the future of wood construction. The project conceived the office building as a structural skeleton capable of housing space in permanent fluctuation and of expressing by itself its architectural and material qualities without depending on the presence of other layers. From its synthetic nature, the structure embodied much more than the mere solution of load transmission or the stability of the building. Rather, it brought together in its own reality the material, atmospheric, and orderly dimension of the project, while enhancing its performative capacity, maximum efficiency, maximum capacity. We propose a system that solves by means of a single constructive component the structure, the floor, the ceiling, and the spaces for the distribution network on the facilities inside the building, expanding the range of flexibility for the organization of the plan. This construction system was developed in collaboration with the Swiss wood construction company Blumen-Lehmann, who developed the construction methodology and may have supported the construction process with the development of part, technical accompaniment, structural prototype, and eventually the construction of the building. The supporting structure consists of a system of columns and a wooden slab covering a span of, the building has a trapezoidal floor plan and contains 4 main floors in a wooden structure and 2 in reinforced concrete in the basement. The supporting structure consists of a system of columns and wooden slabs covering a span of 18 meters. The slabs are composed of unidirectional strip with a hollow cross-section of almost triangular shape that is shown in this section, with a static height of 1.6 meters and a width of 8 meters. The upper slab has a cross-section of between 200 and 250 millimeters and made of cross-laminated timber and work in tension and compression respectively due to the bending of the longitudinal beam and in addition in bending and cutting due to the cross-load behavior. The inclined element of the section work to the shear due to the curvature of the longitudinal beam of the section. In this image are represented the result of the static calculation performed by Joseph and his team of a selected wooden beam. A discrete prop and mooring model is used, as well as a shell model, and several options are analyzed showing that the proposed structure has a huge potential to be optimized in additional design stages. In the left side, there is the development of the facade developed by Pierluigi da Conto. In this image are represent in its maximum dimension are limited by the transport possibility. In order to avoid a strong transfer of tensile load at the joint, the slab element will be assembled using post-tensioning cable linked to the wooden element located at the top and bottom of the beam. The corresponding area will be extended using solid wood blocks. The well-known post-tensioning technology of reinforced concrete structure will be adapted using 4 0.6 inches wire placed in the steel duct filled with injection mortar after post-tensioning. Anchor head will be placed at the end of each of the beam. The static calculations show the post-tension cable can easily take up to tensile forces. The beams, with a span of 18 meters, are supported by solid columns with a cross-section of 300 by 700 millimeters made of laminated wood. The direction of the beam changes by 90 degrees from one floor to another. This allows all the beams to be supported every 18 meters, and the beam has a vertical traction cable up to the floor, to the upper floor beam. 2 large and 2 smaller core built in reinforced concrete and with a circular floor plan are activated to resist lateral load as well as wind and earthquake. The static calculations have shown that seismic load can be taken by massive cross core with minor tensional effect only. Due to the high stiffness of the post-tension slab built with flat wooden plate, the load transferred to the core can be easily controlled. The structure was robust and economical, ensuring an efficient and flexible construction procedure in on-site. Unfortunately, we got the second prize in the competition, so we couldn't see the further development of the system, and we are looking for new opportunities. So if you know if there is something around that can be that we can use this system, we will be very happy if you share that information with us. Thank you very much to you all. I hear it's the whole team that participate in the construction that had two different stages. The first one was a pre-selection of the team with the conceptual proposal, and then a development stage, which is what I showed you today. Thank you so much.
Thank you very much.